Welcome to this video on machine learning, what you need to know. This guide focuses on successful AI agent implementation, covering technical challenges, ethical responsibilities, and governance frameworks for building trustworthy AI systems. It is aimed at tech leaders, developers, and business strategists. This program is brought to you by the Series of Thoughts team as part of the AI Foundation series. Our roadmap to AI agent mastery covers 5 critical areas: integration challenges, trust and transparency, governance frameworks, ethical guardrails, and human-AI collaboration. We will detail how to deploy AI agents at scale to deliver real value and maintain accountability. In the AI deployment landscape, organizations are rapidly deploying AI agents. However, the gap between a proof of concept and a production-ready system is significant. Understanding this landscape's full complexity is the first step toward getting implementation right. AI agents promise autonomous decision-making and scaled expertise. However, the reality is that most deployments face significant friction, including legacy system integration, data quality issues, and workforce resistance. Without a structured approach, over 60% of AI projects may fail to reach production. Chapter 1: Integration Challenges. To deliver value, any AI agent must be successfully embedded into the technical and organizational fabric of the enterprise. This initial integration phase is often where many AI initiatives fail to gain traction. Integration is complex due to technical hurdles like legacy system compatibility, requiring custom adapters for old systems. Data pipeline readiness is essential, as AI models rely on consistent, high-quality data. Finally, ensuring scalability under load is critical for models to perform reliably in production. A proven path to successful deployment involves 4 stages. Start with an audit of legacy systems, then architect the necessary integration layers. Follow this with a pilot in a controlled environment, and finally scale the system widely with continuous monitoring. Investing time upfront prevents costly rework later. A common pitfall is underestimating data preparation. Data quality is a prerequisite, not an afterthought. Key aspects include completeness, consistency across systems, currency to reflect current reality, and accuracy validated against ground truth. Chapter 2: Building Trust Through Transparency. Trust must be engineered into your AI system from the beginning. Without transparency, even highly accurate models will be rejected by users, regulators, and stakeholders. AI systems lose stakeholder confidence because of the black box problem. Deep learning models are often difficult to interpret, preventing auditing and eroding trust. The cost of opacity includes financial loss, reputational damage, and regulatory fines for unexplainable decisions. Making AI decisions understandable requires an explainability toolkit. Use SHAP and LIME to explain individual predictions. Feature importance reports. Visualize variable influence. Decision audit trails log prediction details for compliance. Plain language dashboards translate model behavior for business users. The key principle is that transparency enables accountability, and accountability enables trust. When stakeholders understand how an AI system reaches conclusions, they can challenge, improve, and ultimately rely on it. This also speeds up regulatory approval. Chapter 3: Governance Frameworks for AI. Robust governance is the scaffolding for your AI operation. Without it, even well-intentioned deployments can drift, fail, or cause harm without anyone noticing until it's too late. The 4 pillars of a robust framework are: policy and standards, defining how AI is built and used; roles and accountability, establishing clear ownership; monitoring and review for continuous detection of model drift; and compliance and audit, ensuring alignment with regulations like GDPR and the EU AI Act. Governance applies across the entire AI lifecycle, from data collection to retirement. Embedding controls at each phase, including consent, bias testing, approval gates, and drift detection, is the hallmark of a responsible AI program. Deciding who owns AI governance is critical. The AI Review Board, a cross-functional body, evaluates high-risk deployments and holds veto power. Meanwhile, distributed model owners ensure accountability by having named owners for each system's performance, compliance, and ethical behavior. The compliance landscape is evolving fast. Key regulations include the EU AI Act, a risk-based framework for high-risk systems, and GDPR, restricting automated decision-making. The U.S. AI Executive Order provides federal guidance, and sector-specific rules apply to domains like financial services and healthcare. Chapter 4. Ethical Guardrails for AI. Ethics in AI is a hard engineering requirement. Guardrails must be designed, tested, and maintained with rigor to encode fairness, prevent harm, and protect human dignity, just like any other system component. You must design against core ethical risks. These include algorithmic bias, where models perpetuate historical inequities, and unintended harm, where narrow optimization leads to catastrophic side effects. You must also guard against privacy violations and accountability gaps, where responsibility for errors is unclear. Engineering fairness into your models involves pre-training and post-training interventions. Before training, audit data for gaps and use resampling or synthetic data. Post-training, run fairness metrics, apply calibration, and conduct red team evaluations for bias. Responsible AI is built on 5 core principles: safety, ensuring systems cause no harm; fairness, achieving equitable outcomes across groups; transparency, enabling stakeholders to understand decisions; accountability, assigning clear ownership for failures; and privacy, protecting personal data and consent. Before every deployment, use an ethics review checklist. This includes an impact assessment to identify potential harm and high-risk failure modes. Conduct a bias audit across all demographic subgroups. Complete a privacy review for data use and consent, and establish an accountability map for every foreseeable failure mode. Chapter 5. Continuous monitoring in production. Deploying an AI agent is the starting gun for ongoing operational responsibility. Models degrade, environments shift, and continuous monitoring is essential for sustained AI success. Model drift occurs in 2 forms. Data drift happens when the statistical properties of incoming data shift over time, causing performance drops. Concept drift occurs when the relationship between inputs and the target variable changes, often requiring model retraining. A production monitoring stack includes 4 components. First, a performance metrics dashboard with real-time KPIs and alerts. Second, data distribution monitoring to detect drift early. Third, prediction confidence tracking to identify when the model is in unfamiliar territory. Fourth, feedback loop integration to capture ground truth outcomes for continuous retraining. Good monitoring can be measured by numbers. Target under 24 hours for drift detection time to alert. Aim for a 99.9% uptime SLA with graceful degradation. Ensure 100% decision logging for full auditability and hold a minimum weekly review cadence with stakeholders. When things go wrong, follow an AI incident playbook. Detect, contain, investigate, and remediate. Speed is critical. The longer a failing model runs, the greater the potential harm. Every deployment needs this playbook before going live. Chapter 6. Human-AI Collaboration. The most successful AI deployments amplify human capabilities. Designing the right collaboration model between human judgment and machine intelligence is one of the most consequential decisions you will make. There are 3 primary patterns of human-AI teaming. Human-in-the-loop requires human approval for every decision, best for high-stakes situations. Human-in-the-loop allows AI autonomy within parameters, with human monitoring and intervention. Human-out-of-the-loop is fully autonomous for low-risk, predictable tasks. The collaboration pattern must match the risk profile of the task. As systems mature and trust is established, organizations can progressively shift toward greater autonomy, but they must always maintain the ability to revert quickly when conditions change. Workforce readiness is half the equation. Employees who feel threatened by AI may resist it. Proactive change management is crucial. Communicate the AI's purpose, involve frontline workers in design, and reframe AI as a tool that elevates human judgment. Upskilling is vital for the AI era. All employees working with AI need baseline literacy to understand what the model does and when to override it. Specialized roles require deeper technical training, including AI literacy programs for all staff and clear escalation paths when AI fails. Designing AI interfaces should support human judgment. Surface confidence scores alongside recommendations, making it easy and frictionless to override AI decisions. Also, explain the top reasons driving recommendations to build trust and allow users to catch errors. Chapter 7. Measuring real business value. AI deployments must demonstrate measurable business impact. Vanity metrics are not enough to justify the costs and risks involved in implementing new AI systems. Use the right metrics for AI success. Focus on 4 key areas: Operational efficiency, such as reduced manual time and errors. Revenue impact, measuring uplift in conversion rates. Risk reduction, including a decrease in fraud losses. And customer experience, improving NPS and response time. Illustrative AI value delivery shows that most deployments require 3 to 6 months before value exceeds costs. Investing in governance, monitoring, and change management helps organizations reach break-even faster and sustain higher long-term returns. Avoid the value gap by fixing common causes of underperformance. These include misaligned success metrics, low adoption rates, scope creep, and poor feedback loops. The fix is defining business KPIs early, running adoption tracking, scoping agents narrowly, and building outcome feedback into the data pipeline. Chapter 8. Building an AI-ready organization. Sustained AI success comes from building the organizational capabilities, culture, and infrastructure to deploy, operate, and evolve AI systems continuously and responsibly. The AI maturity curve starts with experimenting, moves to operationalizing with first models in production, then scaling with a platform approach, and finally, leading as an AI-native organization with continuous learning. AI-ready leadership champions AI literacy at the top and must create psychological safety for experimentation. Progress requires a culture where teams feel safe to fail fast. Leaders must also invest in continuous learning to keep pace with the rapidly evolving AI field. Emerging trends shaping AI deployment include agentic AI, autonomous agents executing complex workflows, and multimodal models, reasoning across different data types. We will also see a rise in AI regulation and edge AI deployment for real-time decisions on device. The Trustworthy AI Deployment Blueprint shows 6 reinforcing pillars: integration, trust, governance, ethics, monitoring, and culture. True trustworthiness requires all 6 pillars working in concert. Here are the key takeaways. Integration is a prerequisite, trust must be engineered with transparency and audit trails, and governance never sleeps. Ethics and performance are not in conflict, and humans are your greatest AI asset. Start your journey with a 306-090-day action plan. Days 1 through 30. Assess current initiatives. Days 31 through 60. Architect governance and start literacy programs. Days 61 through 90. Activate monitoring and measure against business KPIs.